Video, we are going to take up one more mechanism, which is called Scotch Yoke Mechanism. So the Scotch Yoke Mechanism is a simple mechanical system used to convert the rotary motion into linear reciprocating motion, which is back and forth motion. So it is commonly used in valve actuators, the slotting machines, the reciprocating pumps, and IC engine models, which is for education purpose. So basically, it consists of the crank, which is the rotating disc, which rotates about the fixed center. Then we have the pin, which is the crank pin attached to the crank at some radius. Then you have yoke, that is the slider with slot, which has a straight slot which moves linearly. Then we have the frame which supports the entire mechanism. So the working principle is as the crank rotates, then the pin moves in the circular motion. Then what happens? The pin slides inside the slot of the yoke. The pin slides inside the slot of the yoke. Then this forces the yoke to move linearly or to reciprocate. So the stroke length will be equal to the 2 times the radius, where r is the radius of the crank. So if crank radius is 36, then the stroke length will going to become 70. So that is what I wanted to prove by using the fusion for animation. For that, what we need to do. So the first part, what I need to create is this one, which is the frame. So to do that, I will come down to the fusion. I will click on sketch and I will go for the top plane. And then I will create this slot, that is the circular slot. Go for circle slot, center to center slot. I will click first center. Then I want to give the dimension, which is 174 minus 20 to 40. So that means 174 minus 40 becomes 134. So I'll go for the dimension to take this dimension as 134. Okay. Then I want this radius to be 10 on this side. Similarly, obviously, in the other side also, you will have this. I will take the constraints of midpoint to this. I will have the one particular portion. So once you do that, now I will go for this point, which is a 6 mm depth. I will go for power design and make it hybrid. Okay, convert. Now I'll go for finish sketch and I will go for extrude. You select this and give the distance as -6. Okay. New body I will take. So then once you do that, I think it should be radius 20. So I'll just go to this, go to edit sketch and give the dimension as 20. Okay. So you have this, select this and I will try to take it out so that you will have the better clarity. So if at all I don't want the dimension, sorry, I want the dimension and remove the constraints. So this is the dimension of the slot, what I want to do. And then I'll go for finish sketch and the extrusion depth is -6. That is what I have given. That is for the base of the frame. Then I want to create a circular pin of diameter 12 to a height of 18. So to do that, I will go for sketch, click on the top plane and I will go for circle and you select some circle and go to diameter as 12. And then I want that to be coincident from this with reference to this. So that is the diameter 12 to a height of 18. That is the height of 18. That is the one what I want to create now. So I will go for finish sketch and go to extrude, select this portion and give it as 18. Okay. Then now I want to create this particular portion, which is the one what I want. I'll go for rectangle. I'll go for sketch, click on this, and I create one orbital rectangle of some dimension. Okay. Then that is 63 mm from the center. I will go for dimension from this point to this, sorry. Then I'll go for dimension from between this point to this. I want to make it as 63. So you give 63 here. Then once you do that, then the width of this is 8. Okay. Go for dimension and give the width as 8. Then this length is 22. Then take this dimension and give the dimension as 22. Now I want to place this at the center. So you take this as 11 mm. Now everything is constrained. Now I will go for finish sketch. Then what is the height of this? It is 34. So you go for extrude, select this dimension and give 34, and it has to be joined. 34, and that has to be joined. Now once you do that, now I want to go for chamfer. You select this edge and also this edge. And I want the equal chamfering of the dimension as 5. Once you do that, now I want to create a slot now. The slot should be 8 mm width and 4 mm depth. So it is from the 18 mm from the base. I will go for sketch and I will create one rectangle here of any dimension first. Then I will go for dimension. This width is 8. Okay. Then this depth is 4. Yes. Then from here to here it is 18. Yes. Then I want to give this dimension from the center. Want to give the dimension from this to this to be 4 mm. Okay. Once you do that, so all the dimensions have been constrained, then go to finish sketch and go to extrude. And now you go for select this one and give the distance as through all and go to finish and cut it. So we have the one portion is over. Now I want to go for mirror. So command is create as mirror. So you go to features, you select this as one feature, then this as the second feature, and this as the third feature. So you mirror plane about this one and say OK. So once you do that, so the first part of the model is over. Now I will go for appearance and take this as yellow and then close it. Now I will go for save, which is called the frame. Okay, now. So the first part is over. Now, then we'll go for the second one. So which is the second one? The second part is what I want to create is the second one is this. So first I will go for design, convert this into hybrid and say convert, and then go for sketch. I will take the top plane, then create this diameter 88 first. I will go for circle, create some arbitrary point and go for diameter as 88. Okay. Then go to coincident, this point with reference to this, and I will go for again create one more circle here, which is at the center. So let us go by one by one so that it will become easy for you. And then I'll go for dimension and you give the dimension as well. And then go to concentric, this with reference to this. Okay. Now the next point is I will create this pin, which is of diameter 8 and this 36. Okay. Then I will go for circle and I will create one circle somewhere here. The diameter is 8. So I'll go for dimension. I will go for the diameter is 8. Then I want to go for horizontal. This one with reference to this, it becomes horizontal. Then I will go for dimension between this point and this point and give the dimension as 36. Okay. After that, I want to create the slot here. I'll go for slot. Go to slot, center to center and arc slot. I will take the center point of this onto this slot. similarly on this side and give this dimension. Now what I will do, then I will go for line. I will go to construction line. I will take from the center of this to center of this. Similarly, I will construct one line from center of this to center of this. Then I want to give the dimensional constraint, which is dimension is radius 28. Okay. Then I want this radius to be 3. Okay. Correct? Yes. Then I want this angle between this and this is 66 degrees. Okay. So all the dimensions have been made. Now we will go for the creation. I will go for finish sketch and I will go for 3 dimension. I will go for extrude. You select this portion and I don't want this to be selected and I don't want this to be selected, and give the distance as -6. Okay. I want to go down, create it as a new body. Okay. Then I will go for I will enable the sketch. Now I will go for extrude, select this portion, and I go to distance as through all. Then I want to flip and I will cut it. Then I want to go for extrude, select this profile and give the distance as 6 mm. Okay, to the top, and I want to join them. Then I will go for fillet between this edge and this edge and give the radius as 3. Okay, fine. Now I want to create this orthographic, this one, sorry, this feature. So I'll go for create and I will go for pattern and then I will go for circular pattern. Now I want to select this feature, sorry, not this one. Okay, I go to create and I go for pattern, okay, circular pattern. You select this as the feature and then the axis as this. Then I want to copy this at 3 identical locations and then say OK. Now once you do that, now I will go for appearance. Now I will take this portion and I will say close it. Now we have the second part has been completed. Now I will go for save. This is crank. Let's say crank. I'm going to save this. So then I want to go for the creation of the last part, which is the yoke. So now to do that, I will go for this portion and I will create this particular pattern. So to do that, I will go for sketch, click on the sketch top plane and go to create and go to slot, take center to center slot first. And the dimension of this is 72. I will go for dimension, take this dimension as 72. Then I want the radius of this to be internal slot of radius 4. Okay. Then I want the constraint to be midpoint of this onto this. Okay. Then again I will go for create and then I will go for slot. Again you create one more slot of some dimension and go to dimension and take this dimension as 72. Then I have the radius of outer one is radius 10. You take this and give the radius as 10. Then I want to go for constraint, select on the midpoint of this slot to be the center of this. So we have both the parts have been completed. I mean, both the slots have been completed. So let it be having a proper this thing so that you will be able to create the model. Okay. Then I will remove the constraints. Now you can see this is the actual dimension what I want for this particular slot. So once you do that, I will remove the dimensions now and then I will go for rectangle and I will create one rectangle of any dimension. Okay. Then according to this, what I want is from the center, it is 111 on one side and 111 on the other side. And the width is 8 and from center it is 4. So to do that, Okay, now I will go for dimension. I will select this dimension, which is 8. Okay, then I will go for from this endpoint to this slot. I will take this as 4. Then I will take from this dimension to this will be 111. Okay, similarly on this side, I want dimension from this to this. I will take 111. So once you do that, so the entire portion is completed. Now I'll go for finish sketch and I will go for extrude, select this profile and this profile. Okay, similarly on this side also, and take this dimension as 4 mm. Okay, either can be to the top or to the bottom. There is no issues for this. I will just go for OK. Then I will go for this and make it as hybrid and say convert. So now this portion is also over. Then I will go for appearance and take this as red. Okay, and say close it. Now all the dimensions, all the parts have been created. Now I will go for save. Now I will go for yoke as the part model. So once you do that, now we will go for the assembly. So to do that assembly, so the first part what I want is the base, which I want to be loaded onto the assembly model. So I'll go to this and make it as a hybrid and say convert. So the first part what I want is the frame, which is fixed automatically to at the center of the origin, and that will going to be grounded. I will just click on OK. Then the second part what I want is the crank. You just take the crank and place it here on the object, and now I will try to move it out and say OK. So this has got all the degrees of freedom so that it can be moved in whichever directions you want. So I will go for joint. I will select this top surface of the model at the center point of the pin and to this. So now it is sliding, but actually what I want is I want the motion to be revolute. So I will just go to revolute now. Okay, and I will say OK now. So now the next part what I want is, now if I keep it from the front view also, you can see there is a gap here. Okay, because the total distance is 18 and this dimension is only 6. So the dimension becomes 12. Now I go for yoke and you select this and you place it here. Again, I will try to move it here. Then I want to rotate this by an angle of 90 degree. Yes, you rotate it by 90 degree and say OK. So once you do that, now I want to assemble this onto this. That means the base of this particular portion to be the base, the middle point of this. So to do that, I will go for joint. Take the surface on this and bring that point here. Bring it here. Click on this side and similarly take the surface here and observe the rotation of that pin. Yes, you keep it on this side. So now, since my previous command was the revolution, so your yoke is also being revoluted, but I want that to be flipped. So you will get it in this particular direction. Yes. Then the motion should be a slider. You just click on the slider. So now you can see exactly how it is moving out. Okay. You go for preview motion. Now you can see it has been, I will go for fit. Okay. Now it is been moving in this particular direction. So I will close this and I will say OK now. So this has got a slider moment. That is, the yoke will have a slider moment and this one will have a rotational moment. Okay, I will just go to revert position. So now what I want is, I want to place, I will go for the top plane. Okay, now I want to place this slider approximately at the center of this. Okay, like this. Okay, then I will go for establish the motion link. So contact, I want to establish a so all these are assembled now, but the basic difference is this is a separate one and this is the separate. So that means this crank has been fixed to the base, and the slaughter is also fixed to the base. That means the slaughter is the yoke is sliding with reference to the base, and the crank is also rotating with reference to the base. But what I want is I want to establish a contact between the crank and the yoke. So to do that, I will go for assemble, enable contact sets, and I will just go to right click, create a new contact set. I will take the body, select this crank and also this yoke, and I will say OK. Now, if I go to relationship and if I try to revolute animate joint relationship, now you can see that as I rotate, as the crank is rotating, then this slot, the yoke will going to slide in the vertical direction. So what is the basic concept here? This stroke has got 72 mm. So once it becomes the 36, that is the diameter 72, then the linear, when the revolution takes at the radius of 36, then it will, the moment of this will going to be having 72 mm moment of the stroke. So now I will try to establish that point. I will go for a sketch, click on this sketch. Okay. I will go for line. Okay. I will take, I will go for project. Let us say I will go for project and I will select this point. Okay. And I will say, okay. Now I will go for line. I will take the center point of this and I will draw a distance of 72 mm. Okay. Now, once you do that, now I will just go to the slider. So this obviously this will be 36. Okay. Now, as I go to revolute and animate joint relationship, now you can see that as the crank rotates by a radius of 36, this will going to have a rotation of 72 mm. So that is how I will be able to prove that the as the crank rotates, the stroke length will going to be the 2 times the radius. So now I will just go to this and can be able to have this dimension, animate joint relationship. So the dimension is moving out. So here the length of the stroke is 72. The radius of this will going to be 36. So that is what I'm trying to establish, that particular relationship. That is what we are trying to say here. If the crank radius is 36, then the stroke length will going to be 72. So if the crank radius from here to here it is 36, then the stroke will be from this point to this point will going to be 72. This is how I will be able to prove that the Scotch Yoke mechanism of the kinematics of machines, where the rotary motion of the crank will reciprocate the slider motion of the yoke. Thank you.